Now let's see the concept of leaky bucket. In this concept, what happens is, why this name leaky bucket is given is, you can assume that there is a bucket and now there is a tap, and through the tap you are going to get a inflow, and that inflow is varying and it is bursty. But then if you assume that there is a hole at the bottom of the bucket, then through the hole there will always be a fixed flow, right? So ignore the fact that the pressure or the speed at which the water flows out of it depends on the pressure and the weight here. Ignore that, but you can assume one thing: whatever is the inflow, the outflow is always fixed. So this is the property which we wanted to apply even at our computers, right? So what we want to do is, at the sender, even though the sender is producing bursty data, we don't want to send the entire data outside all at once. We want to send it at a constant rate. That is why this leaky bucket concept is being used here. Okay, so it doesn't mean that inside the host there is something called as a bucket. Okay, so it can be implemented in a other way. So let's see how it is implemented. Now that bucket is implemented in terms of something called as queue, which is nothing but a buffer. Now as the packets are arriving, okay, as the packets are produced, we shall first see whether the queue is full or not. In case if the queue is full, we will not be able to take any more data. In that case, we are going to discard the packet. In case if the queue is not full, we shall take that particular arrived packet and we will put it in the queue. Got it? And now from the queue we take out the packets at a constant rate and we keep on sending them out. So this is, you can assume that this entire concept of queue is like a bucket, and this is the inflow and this is the outflow. Whatever is the inflow, the outflow is always going to be constant. Now how do you apply it to the real packets is, so if we assume that the outflow has to be, let us say, 100 bytes per second, that is the outflow you want to maintain. Now we have packets here. How to send out the packets? So we have to send the packet all at once, right? So what we do is, we shall wait for 1 second. Let us say the packet is 100 bytes, right? Each packet is 100 bytes. Then we shall wait for 1 second, and every 1 second we shall keep on sending out one packet. And now if you do that, you are actually maintaining a rate of 100 bytes per second. Got it? So that is how it is implemented. In case if the size of the packet is not constant, if each packet is of different size, then you have to wait for the time till you accumulate those many bytes. So what I mean to say is, you can have a counter here, and this counter can be incremented by 1 every second or every clock tick. You try to maintain a counter. Let us say 100 bytes per 1 second means every 1 second this counter is going to be incremented by 100. Now let us assume that your packet size is 200 bytes. Okay, then first second it will be incremented by 100, second it will be made 200. Now the packet size and the counter you have here are both saying that yes, you can send 200 bytes now. At this time 200 bytes will be sent out. Got it? So especially coming to this leaky bucket, they will not be asking you anything related to the packet size. They will just ask you the entire buffer size and what is the inflow and what is the outflow. So we shall see what are the questions and how they could ask you on this topic. Then you will understand whether to use this implementation or not. Okay.